So, I guess it's been quite a while we haven't seen each other. So I hope you still remember, but I will quickly review the topics and then hope to able to finish at least half of what we're supposed to do. So what we working on is hypothesis testing. The idea is being that from last topic's estimation, right? Estimation is you get a data, and from that data, you try to guess what happened in the overall population, right? So the main idea is like I want to know how much people willing to pay for a new product, right? And if I ask everyone, then done, right? There's no need to study statistics. But you are unable to ask everyone, right? So you have to pick up some people, what we call market research, right? And then we study some of them and then ask them how much they're willing to pay, right? And use that information to guess what happened to the whole market, right? It is something like you need to do. Suppose you want to enter the market in mainland China. We have 1.4 billion people, right? No way to ask 1.4 billion, right? So only you have to do is to go to each city and try to ask some people and to get some idea. And that is what was estimation. And hypothesis testing is kind of like a reverse concept, okay? Estimation is we don't know what happened in the population. We try to get data to guess, okay? And hypothesis testing is like we have a guess on what is actually in the population. We want to see if this is true, okay? The idea is like suppose we are talking about the willing to pay, right? A new product, right? And we guess the new product is willing to pay is like $100, right? And you want to see if, say, suppose a new feature, is it going to, people are willing to pay more for that, right? So that's a question, right? And that is the question. And the way we learn from this topic is pretty mechanical, okay? We don't teach the idea, we teach the relative intuitive idea behind, but we really don't go to the reasoning why they work, okay? And why they work is beyond the scope of our business statistics class. You'll be covered in the stat department if you really want to do it. We just look at the procedure and we try to explain why there's a reason behind this is true, but we're not going to detail why they're true, right? Unlike estimation, we justify the consistency and biasness, right? This kind of property, but we're just saying that what we're doing is this, okay? This is what we do, and this standard procedure apply everywhere. And to regard as hypothesis testing is something we want to claim, or the claim on population want to test it. And the two type of claim, null or alternative, called H null or X0 or X1 or XA, right, as alternative. So this is the idea, okay? And remember the null is always simple, the alternative is always composite, okay? And the important part of composite have two different types. It's one side and two side, okay? And one side have left or right. And when to use what will be very clear for your test or exam, right? But you should be able to distinguish what, right? The idea is behind is what happened, or you might know what the deviation can be, what variation can be, right? Just like this question, the example would be, you would want to take some changes when the mean age of customer is more than 45, then you want to X1 to be more than 45, okay? So because less than 45, then you will not do anything. So that is the idea behind one side, two side, right? And if you really want to say as an auditor, you want to make sure that it's exactly this number, okay, 3,000 revenue, then you really want to have a two side, right? More than or less than is a problematic, okay? So that is the idea behind. And of course, in general, as we see, most time is you don't know where the most common thing is two side, okay? But one side is still there. Yeah. And the main idea is not that difficult, right? The idea is we want to test make a statement about the sample mean, okay, or the population mean, right? And the main idea of hypothesis testing is the following, right? Just to let me recall it quickly because we will do the procedure very soon, right? The idea is we have a statement about, say, for example, whether mu is big or not, right? It's too big, then we reject, okay? And the idea is if the sample mean you collect, right, which is the guess of our mu, right? And if X bar is very big, right, then we would probably favor X1 or rather than X0, right? The idea same in the courtroom, right? Imagine the murder, right? If the guy is guilty, right, of murder, then maybe he or she is have a conflict with the victim or was there in the location where the murder happened, right? Or they've quarreled before it, or their money conflict between them, then or he has his t-shirt have some blood, right? Then probably you will be think you think that's the case, right? Same idea here, right? If we found the H1 is more than it's large enough, then you will reject. Okay, you reject the H now rather than you will take the H1 alternative. Okay, so let's see the example that we will do, and just to remind you, this slide is we have type 1 error and type 2 error. Probably you forget. But type 1 error is very simple. Is the null is true and you reject it. And this alpha is the exactly can control directly. So we'll specify the alpha. Alpha will be 10%, 5%, or 1% in general. Okay, it's the things you can control. We will be specified again more later. Okay, beta is something we can't control. Okay, but that being said, there are two types of error. If you reduce alpha, you increase beta. So there is no free lunch. Okay, so if you want to get smaller alpha, then you have a much bigger beta. But that is what you need to know. So that's why you may ask why why have 5% alpha, right? Why don't have 1% or 0.01 as small as possible? The problem is when I have small alpha, the beta will be big, but we don't know how to measure that. Okay, and that's why rule of thumb we always use 5%. But that is that's a tradition. So there's no hard and fast rule to tell you why 5, but everyone use 5%, so we follow the tradition. Okay, so remember the alpha is the significance level. Okay, so that means that we can decide alpha, right? And p-value will be the smallest alpha that reject action. It will be more clear later when we introduce the rule. Okay, but let me tell you the this procedure we'll do for the rest of this chapter. Okay, we will state what is H now H1 given from the question, and based on the question nature, you would calculate test statistics, and then based on that, look at the table or use Excel, you figure out the answer. Okay, so it's very simple. But step 1, based on the question, usually will be very explicit, right? Or you can infer from the question. Step 2 will be basically based on what we're doing, and 3 is look at the table. So let's become more specific now. Okay, let's go back to the problem of sample mean. We want to test sample mean. Okay, at the very end we talk about sample variance, but we talk about the mean first. Okay, and the main thing here is distinguish is whether is Z or T. Okay, we'll talk about Z today, and the second half we'll talk about T. Okay, the first half we'll talk about the Z before the break. Okay, and if we know this sigma square, then we use Z. Okay, otherwise T. Okay, and probably you would ask, okay, how can we know sigma square? Okay, usually we don't know. So basically, most of the time you do T. Okay, and the way that's why I do Z is, as we said, right, when N is super large, Z and T the same. Okay, that's one thing. Second is and sometimes we have a good estimate of sigma square, right? If I told you, if normal, right, you have the range, you divide by the 6, that is a good estimate. right? Although upper bound can be usually larger, but for hypotesting, as you will see, an overestimate or sigma square doesn't really matter anyway. But anyway, we just follow the textbook. So this is, I don't think you would worry too much about that, okay? So the idea is the following, okay? The idea is now I have sigma square, okay? And what we do is the overreaching assumption, what we do is we have a null, okay? We assume this is true, okay? And see if the evidence against it or not, okay? So that's the same in the courtroom. Assume the defendant is innocent. See if you sufficient evidence that is beyond reasonable doubt that he's guilty. Okay? So the idea is, what we do is we will have the sample mean following the bell curve, right? So assuming this is true, what we know is the data we collect, okay? We calculate the sample mean will be a will be a bell curve, right? And what is the location of the bell? Under our assumption, right? Someone tell me this A, let us assume that's true, okay? Because that's the idea, right? We assume it's true. See whether the evidence is going to support or not. So it's located at A, okay? And by central limit theorem, right, or the idea that the bell curve is, right? The shape of the bell or how spread out the bell is coming from this, right? Sigma square n, right? If we have larger sample, the bell is squeezed in, right? If the underlying sigma square, right, which is population variance, right, is very condensed, right? This bell is also very condensed. Is that clear for this one? Okay. Now, I think we learned this in 2 topics ago. So the question now is, what should we do about this, right? This knowledge, okay? And of course, what should we do depends on the, depend on our alternative hypothesis, right? So you suppose, this will be up here in the next slide. Suppose mu is bigger than A, okay? So the idea of what we do is, if we will say, right, we will favor X1 rather than X0 if the following happen, right? If the data we have is very large, right? Because I want to distinguish whether it is equal to A or more than A, right? There's this alternative, right? So if it is smaller than A, then you don't really need to do anything, right? Just go home, we're done, right? Just like if you say there's a murder, right? And the guy is not there, right? So suppose the murder happened in Hong Kong. That guy is actually in Taiwan, okay? So nothing happened, right? On the day of murder, right? Unless he has supernatural power to kill someone far away, but right? Doesn't exist, right? Then that's supernatural power. So that means that if it's here, then you don't have to worry, right? The other thing is very large, right? Very large, then you have some issue, okay? Very large. If it's very large, then we will say reject. But how to define very large, right? And you learn statistics, we lose probability, right? So that means that when this is very far, that requires this is very small, right? Because the further away, the area on the right is very small. So that's quantify the probability, right? And how we define very small? That's alpha comes in, right? Alpha said, even though this is true, we'll make a mistake, right? That's type 1 error. So even it's true, it happened with small probability that happen is true, right? So we exactly by our decision rule is provided by our alpha. When we decide on alpha, immediately we tell what is considered small. Is that clear? So small is decided by alpha. If you use 10% alpha, right? This is closer to A. When you smaller alpha, it's further away from A, okay? And this is what we call the critical, this is the value where you will make a decision, right? They're called the critical value. But usually in the classical way, right? We don't do this directly, right? Because you know, this number is nothing difficult, just this, if you learn, it's just this, right? Right, this number, sorry. Right, if you learn this exactly this number, right? But the classical way to do this is not to do this in the X bar dimension, The standard way to do, if you follow any textbook, they will tell you that you should do this, convert it to Z, right? And because the same thing here, right? This is convert to 0, and this convert to, right? This is alpha here, right? If alpha is here, this is called Z alpha. And because Z alpha is a critical value, right? That means that you collect the data, right? Suppose your data is somewhere here, okay? Then this belong to here, right? Then in that case, you don't have enough evidence to say H1 is true, right? So you keep your H0. Is that clear? And if our data is happen to be somewhere here, okay, then it's here, right? Just convert it. Then it's belong to here. Then you would reject H now and take H1. Is that clear? Okay, of course I'll do another example to make sure it's clear. And probably ask me one thing I didn't mention is p-value. How to do p-value here? P-value is exactly this value. Okay, is suppose the data is this one. You just change the alpha, right? Such that just reject, right? So basically, you get data is a light purple one. You look at the area exactly on the right hand side, right? That will be exactly the p-value. So don't worry, I'll give an example, but this overview, okay? I'm sorry that today's class is, we will repeat many things again, and again, okay? You'll be very boring, but just to make sure that you understand, okay? It's a boring class, I would say, but it's very important. Although I say it's boring, but today's idea is very important because hypothesis testing is the last thing we learn from this class. Other than that, it's just ANOVA and regression. It's just applying what we learn, okay? In a different context, but is that okay? Okay, don't worry, we'll give example. Let's go to the example and then you will see how we are going to handle this, okay? I just have said, so let's see the example, okay? So this example that will be very similar to the assignment. Of course, you expect something similar to exam, but of course, in the exam, probably I will just use verbal, but rather than not this directly, right? Probably you have to tell me which is which, okay? From the verbal, right? Maybe I would want to say, we want to have a hypothesis testing where the mu is bigger than 6, right? Something like that. I mean, you see example, you will see. Or you have seen the sample question already. You will know what I'm asking. But that is very similar to what you expect to see in the assignment or in your exam. Okay, but that is don't worry. That's something not very difficult. So just as I said, we just apply the steps. So this is step 1, step 2, right, and step 3, right. Step 1 is hypothesis, which I spare you the detail of reading. Okay, I give you directly. Okay, but in the test, or you have to infer, right? In application, right? You tell what is what, right? As I remember, I have already specified, right? How you decide, right? Suppose this example, right? A drink, right? If I want to see this low sugar, right? And if you want to as a quality control, right? If you have less sugar, there's no problem, right? Then if you have more sugar than is required, you jump up, right? So one-sided test, right? Or when it's more than, right? It's a volume here is 250. Suppose everyone knows it, right? 250 millimeter, right? And if more than that, then maybe explode, right? So more than is a problem, right? Less than doesn't explode, right? More than can have a problem, okay? So in that case, if quality control, you want to avoid more than, right? So now the question, now we're going to step by step, okay? So now a good thing is we know our standard deviation sigma, okay? If you don't know, we talk about T, okay? So now is that. The sample size N is 64 and X bar is 7, okay? It's good, okay? So I'll not, in this example, I'm very kind to give you N and X bar, right? In the test, don't expect I give N or X bar, okay? You have to know what do you mean by X bar and sigma, right? But I hope now you know what X bar and sigma is, right? Now the question now is, we're gonna test this, okay? So as always, I recommend you start with this, right? We start with H0. What does that mean? It means that with the following, right? By central limit theorem or the normality, this is a bell curve, right? Sorry, the bell is not really nice. It's symmetric bell, right? And center is at 6, right? That's given by the null hypothesis, right? And what we learn is how is the shape of this being determined is sigma squared over n, right? Sigma is here, n is here, right? The shape is designed, right? And now what we left is to look at the alternative, which is more than 6, okay? So that means that if it's large enough, okay, and we reject, and right, how to determine the size? Usually alpha, and alpha we use 5% here. Okay. Although I don't say it, but I always use 5% as a standard. Okay. And as I said, usually it's 5% unless you have some special reason to deviate. Of course, that's the standard. Now, the question, as I said, usually you don't do this, right? Because this is actually, you can calculate that easily, right? But as I said, we actually calculate this guy, Z, right? Because the question is, you want to ask yourself is whether 7 belong to here or 7 belong to here, right? If 7 belong to blue region, it's far away, reject. If 7 is outside the blue region, you don't. That's very simple. But we don't actually do in this space, right? Usually, that all the textbook will tell you, you should commute to Z, right? And this will be 0 here, right? And this number is Z alpha, okay? And you convert 7, 7 is what? 7 minus 6, right? Is minus the mean, right? 7 is somewhere here, either here, right? This is the difference between, from the mean, right? Over the SD, right? Remember what is Z? Z is how much is different from the number, from the mean, by how many SD, right? Let me repeat the statement. Z is how many SD is different from the mean, right? Difference between 6 and 7 is 1. And look at the SD, 6 over root 4 is half, right? So that's why 2 SD here, okay? 2 SD, right? That's why 2. And the question is 2, is it 2 is here or 2 is here? So that's a question, right? Where is it? Where's that, right? So we have to figure out what is Z alpha, okay? Z alpha, that is not that difficult, right? It's 0.05 here, right? That means that this side is what? Is 0.95, right? And, or we can look at this one, is 0.95, or look at the same thing, right? It's 0.95. What is this number is? Excel tells us we can do the following, right? It's norm S inverse. Y inverse is you from area to the number, right? 0.975, so 0.95. Then we're done, okay? And this number is what? Turn out to be 1.64, okay? 1.64. And that means that the case is this one. This is the case, okay? So that means that it's here, right? So deep inside, okay? Deep inside blue region that we reject, okay? So we reject, that's it, okay? Because you compare this number to 2, right? You reject, right? Alternatively, you want to calculate the Z p-score, p-value, right? How to calculate p-value? Your Z is 2, right? So 2 is here. What you want is to calculate this value, right? On the right-hand side of 2, okay? How to calculate right-hand side of 2? You calculate the left-hand side area minus 1, right? The left-hand side area is norm S this 2 true, right? That's give us the left-hand side area. 1 minus right-hand side, okay? So this gives us 2%, less than 5%, then you're done, okay? So the question you ask me, why I teach you the two different ways to do the same thing, okay? So I have to say that this, what we call the critical value method, the first one is called critical value method. Look at the critical value. It's a classical way to do things before machine is so convenient, okay? This is a classical way. Classical. And with computer, this is easier, okay? And that's why they're two-way. And doesn't really matter you use which one, okay? But exam, more likely that you have to use a classical one, right? Because you cannot calculate carry p-value. But I mean, the two are the same, right? So it doesn't really matter. Is that clear what we're doing? Okay. Don't worry, we will do the left-hand side. We'll do right-hand side here. We'll do left-hand side, the same thing, mirror image. Okay. So you will familiarize yourself with that. Okay. Is that okay for this one? Now we go again for the right-hand side. So left-hand side. So there's a question, look at left-hand side. The same idea. Now let me go run with you again this question. We have sigma equal to 4 and 64, okay? And mu is 6, which is the same, okay? So what we have again, let me draw it again, right? X bar here, under the null, right? 6 is here, okay? We know the sigma square over n as a variance, okay? The variance, okay? How big or small is this, okay? Now we are saying that we are not very happy, it's very small, okay? This is our x1, okay? Which you should be inferring from application, right? Why you want to smaller than, but I give you here, okay? So the data we have tell us that x bar is 5, okay? So I want to remind you that if x bar is 7 or 8 or 9 or 10, then you can go home. Right, we're done, right? Because no way it's less than 6, right? It's more than 6. So they say, don't reject, okay? You don't need to do anything, right? But now the question is 5, okay? 5 is here, okay? The question is it far away enough, right? Or we said, is this area is small enough, right? If this area is more than 5%, then we reject. Then now, accept x1, right? But now the question is we don't know, right? So let's check it out, right? It's fine enough, okay? And the way we do is actually you can do it here, right? But as I said, the classical way is to convert it to Z, right? Standardized normal 0 here, okay? And ask what's 5 here, okay? 5 is 1 below the mean, 6, okay? And the standard deviation here, here, okay? The SD is 0.5, okay? And that means that it's 2 away from it, -2, okay? As you can follow this calculation, okay? So we want to see if this is small enough, right? Is it 5% or not, right? That's a question. And that is simple, right? We have number, calculate area, that's the send, that is the display function, right? That's norm as this -2, true, okay? And that gives you 2%, then reject, right? So you reject at 5%, right? Reject at 10%, but if you use 1%, then you don't, right? So how you make the decision depend on your alpha, right? You have to make your own judgment what alpha is good, okay? And in general, alpha is 5%, okay? Now the next question is another way, right? This is done it this way, right? Let me do the other way around, right? Find the critical value, right? Critical value method, okay? What we want to see is, the question is critical value is like this, right? That is it. right? We want to look at 0, look at if this is 5%, what's the number here, right? That's a question, right? But this is just negative Z alpha, right? And remember how to find this guy? Left-hand side is 5%, right? Then just norm S inverse 5%, 0.05. Okay, that gives you the answer. Okay, and gives you negative 1.64. Okay, so then it's like this, right? 5% C. Right? So it's 5%, right? You dip inside the 5% region, right? Then you reject. Is that clear? Let me slow down a little bit because this is very important. So we'll do it again. Okay. Any question? No? No, let's go to the more complicated one. Okay. Then we'll break. Okay. The complicated one is called the two-sided. Okay. Slightly more difficult. Only conceptually. Okay. Is that okay? So the next one is looking at this type of hypothesis, which is the most common one, as I would say, because usually don't know. Okay. So very similar question here. Okay. So again, let me draw the Darwin. Okay. You can see the same question here: 4, 64, and 4, 5, and 6. Okay, same as previous question, except not equal to. Okay, so let's draw it again. Okay, so as I said, today's class is slightly more repetitive, but as I said, but this is very important class, so that's why I have to repeat myself. Okay. I apologize for very boring, but I can't help for that. So the two-sided means that if it is too big from 6 or too small from 6, you would jump up, right? And say, no, I'm not going to support X0, right? Rather, I would take X1, right? What does that mean? It means that the region will be on both sides. And you don't know which side, right? So you put alpha into half into both areas, okay? So what do I mean by that is you reject if it's too big and also too small, right? So, but now I have to put alpha somewhere, right? I don't know, that's why symmetrically, I will put alpha over to here, alpha over to here, right? If it's too big, if too small, then I reject, right? Before it's one-sided, I put all the alpha on one side. Now I don't know which side, so I symmetrically put alpha over 2 on both sides. So that's the most difficult part here. Okay, if you haven't learned before, that was the part that is a little puzzle. Okay, is that okay? So just to remind you a little bit different between one side and two sides is with alpha divided by half or not. Okay, that's the only thing. Is that clear? Okay. So what we have now is this. Okay. So if you convert this, right, to Z, right, this is 0, right? So you will see it is Z alpha over 2, and that is negative Z alpha 2, right? So as long as if data is in this region, then you reject, otherwise you don't. Is that clear? Okay. So now the question is slide 5. Okay. Okay. 5 is somewhere here. Let me use the color. 5. Okay. We want to know whether 5 is here, 5 is here, right? Okay. The question is whether 5 is here or 5 up there, right? Remember, when you do this, you don't know actually 5, you get 5. It may be 7. Okay? And to you, it has no difference, right? So you don't know which side. Okay? Because you determine your alpha before you collect data. right? So the question is, there 5 here or there? Okay. So how to do that? Just remember the same tactic, right? It's -2, right? Because 5 is 2 SD, right? Because SD is 0.5, right? It's 2 SD from that, -2. So asking is -2 here or -2 is here. Okay. So let's do the p-value first because this is a little bit more tricky. Okay. The p-value you calculate is -2 on the left-hand side. This area you have to multiply by 2. Okay. You have to multiply by 2 because you actually don't know which side you're in, right? Actually, before you do it, 5 and the 7 are the same to you, right? Because you don't know which side. Okay. Or remember, p-value is just you have to calculate both sides, right? So if you just adjust alpha such that this is just reject, right? So that's why you have to multiply by 2. So that's why the p-value will be 2 times the left-hand side area is norm S this, right? Because we want to find the area, -2, true. Okay. Remember, p-value have to be multiplied by 2. This is only different for two-sided. Okay. The reason is being that you would, because you allocate the area on the both sides, alpha. So you have to compare with alpha, because you at the end compare p-value with alpha, right? So multiply by 2. Okay. If you don't understand, just remember it. Okay. Sometimes you remember the formula, then you understand. Okay. It's not very complicated. I don't think I understand when I work on it, but after working some assignment, then I know understand why. Okay. So the calculation is 4%, so you still reject. Okay. So because the sum of the area, these two areas add up together, is still less than 5%. Okay. Or you can calculate the critical value, right? Remember 5%, you divide both sides is 2.5%, right? Just to remind you how to get that, right? 0 is here, this is Z, okay? You want 5% on both sides, right? So that's why 2.5% here, right? Because 5% together, total, right? So how can you do this number, right? This is negative C 0.025. This is Z 0.025, right? You can either do this by norm, right? S dot inverse 0.975, right? Because the right-hand side is 2.5, right? The left-hand side must be 97.5, right? Or you can directly calculate this one again, the same. This is equal to normal, standard, inverse, 0.025. Okay. This gives you negative 1.96. Okay. Same thing, because symmetric. Regardless of what you do, that's a number. But anyway, if you do 5%, 2.5%, this number you remember by heart, right? One is 1.96, one is 1.64. So then be something that if you do enough questions, that actually you don't have to worry about that. So I guess I should end here for the break. Okay. Today because we start a little bit late, so we cut the 5-minute short, a little bit shorter. So let's resume at 2:30. I will put up the U reply. You can tell me whether you know, but I will keep this slide for 3 minutes first before I go. I do the U reply. Okay, let's have a break for 10 minutes. I'll go around to answer any question you might have. But after 5 minutes, I put up the U reply. Go around to see the questions. Maybe quickly to the you reply because I want to know how how are you thinking? Oh, sorry. So I appreciate you can spend some time to fill in. Let's do it 3 minutes time so I can know how well you're thinking. And just in the meantime, yeah, let you have a rest first. To save time, let me do some continuous. Oh, please. So, now let's see the result. Many questions about screwing this course. Not sure what it means. Does it mean a lot of question, or this question is very hard? I don't know. Because some of you actually, of course, you will be worried about tests, which I usually do when I do this class. So I would like to emphasize our class because applied nature. So what I taught and what you do the assignment is the thing I expect you to handle, right? So that's the test is actually very similar to the assignment. I mean, I'm not going to waste our time to do repeat exercise, right? So that's actually where I expect you to know, okay? And so since open book, so that the principle that I do the exam is try to make sure that there's a lot of question. Don't expect you do all of them, right? But the idea is like I try to distinguish who is more capable, right? That's the requirement for me, right? Because the school just actually do it, right? That depends on how fast you're doing, right? Of course, I give you 3 hours, everyone can get 100 marks, right? Because it's not very challenging in the sense of difficulties level, but rather how fast you're doing, okay? Just make sure when you go to the exam, please revise your assignment, right? Because that will be very similar. Okay, if you're able to do it fast, then you're done. If you still need some time to read it, figure out how to do it carefully, then you get less perfect score, right? But rest assured, so far for those who took the exam, okay, they would at the minimum would get B level, right? Those people who are not really doing the exam or then they will get C. But so far last year, I think we don't have maybe 1 or 2 people got C, which actually they don't take the exam or just don't do half an hour, just go away. But if you stay there to finish the exam, I mean, B will be B range should be there, right? Whether you get A, depends on how good you are, right? But of course, we don't have as you know, we don't have a limit of who can get A, who can get B, right? As long as you can do it, it's fine. But as you learn statistics, right, you know, unfortunate fact is, no matter how easy I set exam or how hard I do it, I mean, there is always distribution anyway, because maybe you have something to do. You don't like statistics, which I understand. Okay. There's an unfortunate fact Some people is think today is Thursday, but just make sure today is Monday. Although you may be mistaken. Actually, I may be thinking it's not Monday because I actually have a jet lag anyway. So what's weather today now? Yeah, pretty much okay. Windy, cloudy. At least no one thinks it's rainy. That's good. Otherwise, we're living in different universe. Okay. So today, someone think my speed is a little bit too fast. I apologize for that, but we'll do T. Hopefully, that will convince you the procedure of how to do that. Okay. And again, some of you think it's a little bit not easy to follow. Yeah, today's Thursday. Oh, that's a joke. Okay, that's good. Yeah, it's getting cooler. Okay. Actually come back from Beijing this morning and it's pretty cold there. But that's why I still have a long sleeve because I don't have time to change. But try to solve today's question. I don't know what's today's question. What do you call a deer without eye? Oh, that's good. No idea. Okay, it's a good joke. No idea. Don't know how to solve. If question about assignment, please email TA. TA will try to give you a hint without giving you an answer. Okay, so you can try to ask him. Yeah, I need a haircut, I know. And usually I actually don't have haircut, but because I'm afraid of cold, but probably I should. I mean, you're right. I'm too busy, but maybe I should take it during this weekend or. Yeah, I like drink this. Yeah, not really. Usually I drink water, but sometimes I skip lunch, so I need some glucose. Otherwise, my brain doesn't work very well. It's not very healthy, but anyway, you need something. I hope I answered most of the question. Now, let's hope that you not too confused, okay? Because now I'm going to confuse a little bit more because talking about the same thing, almost same thing. But now we don't know sigma square, okay? So I apologize. If you know it already, then it should be very similar, okay? It's not something new, okay? The question is, I have no idea of sigma square, which is usually the case. I have used R square, okay? Sample variance. Do note that, although I didn't explicitly say, there is an important assumption behind if I don't use a sigma square in Z square. Is I'd assume the population follow a normal distribution. There's a bell at the background, okay? So suppose I consider a case where where's the pay for a new product, okay? If I know sigma, that's fine, okay? If I don't know, I have to assume 1.4 billion people, they follow normal distribution. Usually it's not a big deal, okay? In business application. But if non-business application, that can be a little bit easier. But since we're in B school, so don't worry about that. So probably you would ask, when we don't know this, we have to use T, right? Because that is what it said. This is the main result, right? This is the result we learned from 2 topics before, right? That's called the student T, right? If we know sigma, that is follow the bell, right? If you don't know, we replace by S. There is a other bell, but a theta bell, okay? And the bell would depends on the n, number sample size, right? The bigger the n, the smaller the tails, right? It's more closer to the normal, right? Just to remind you, right? If I know the sigma, I know X bar is going to follow this bell, right? With sigma square over n, okay? But the problem is I don't know this guy, okay? I don't know this shape. But I know if I look at this number, this idea, this is look like a bell as well, okay? So 0. But the tail is much fatter, okay? And this fatter bell also depend on the version they have, okay? And the version you pick up depend on the sample size, okay? Don't worry about that. I'll go to example one by one. You will see it's very boring, okay? As some of you actually laugh during the break because they think it's very boring because I do the boring thing today as as I said. Same next class, I'll do boring thing, unfortunately, okay, because, well, I can't help because this is just procedure, the same thing, okay? Let's do the question. The question is the following, okay? I have to assume it's normal, okay? And I collect data of sample size 16, sample mean is 5, sample variance, so sample standard deviation is 2, okay? And the question, which usually I will not give you this directly, right? I will say, I want to test the hypothesis that whether mu is bigger than 4 or not. That's something you do, right? That's you will say, right? But you should infer this is the case, right? Now, don't worry. You will see the assignment, then you will see what I'm saying. So don't worry about that. Or you can check my lecture notes, whether you have many questions. You try that as well. For those of you who think my assignment is too little to have fun, try my lecture notes, okay? They have a lot of question and answer there, so you can try those, okay? And if you still don't have not enough, pick any textbook, find the question, and try to ask the TA, okay? If you really want to torture yourself. Okay. X5 is here, right? They are the same. I know this, right? I know 4 is here under this, right? And the question is, okay, again is, if this bigger than 4 enough, then I reject, right? Still a case is, I want this alpha, okay? And the shape of this again is sigma squared over n, okay? Right, if we know sigma squared, then done is very easy, right? Because we know exactly where to do, right? But the problem is we don't know sigma squared. What we do is, luckily someone proved for us, even though we don't know that, okay? We can look at the t that is doing what we want to do, right? So the question is, the solution would be, look at the t, okay? Okay, and just the same, 0 is here, okay? And I convert this guy to here, okay? So remember the question is, we figure out this is 5, okay? So we want to see 5 is here or 5 is here, right? If 5 in the blue region, then we reject, right? If not, then we don't, right? So we want to see 5 is whether it's here or here, okay? The conversion is same idea, right? And just convert that, okay? That is actually equal to 2. You subtract the mean, right? Asking the one above the mean, and SD is 2, right? Sample SD is 2, right? So 2 is here, okay? And this is a bell. Remember the bell is what bell you're looking at? T bell. Which T bell you're looking at? N minus 1, right? And N is 16. What does that mean? It means that I look at T, the 15 one, okay? The T bell have many versions. You have version number 1, number 2, number 3, number 15, right? The bigger the number, the more closer to the standard bell you have, right? Because T infinity is exactly the normal, right? But we're looking at the 15 one, okay? So look at this number, right? It's very simple. We are trying to see this area, right? The p-value. Then it's not difficult. That is T, right? From the number to probability. So T, this, right? 2, right? And which T we're looking at? 15. True, okay? So the only difference is we have to mention 15, right? Remember, we're looking at the right-hand side area, right? What we have is left-hand side, right? So it's 1 minus. So this is the p-value, and p-value is 3%, so less than 5. Then we'll reject at 5% significance level. That's what we say. Okay, that's a standard way to say. Okay, of course, if you use 1%, then you do not. Okay, if 10%, you still reject. Is that clear? Okay. So there's somewhat variation that I may ask in the exam, right? I will change the number, right? Otherwise, it's too easy, right? But you will see what might be changing there, right? The main change is basically this, and change some number there, here and there, and then that's how I ask, right? Right. This is introductory class, so what I can ask is very limited, right? So you can basically predict with high probability, 95% what I'm doing, right? So you don't do assignment, so nothing I can do a lot, right? So for this class, right, learning can be difficult, but for prepared exam, it's very simple, right? Because there's very limited thing I can do, right? So the other thing, but remember, this is you can't really get from the exam, right? So basically, usually what you do is look at the critical value, right? Look at what is this area, right? And remember, this is T15, right? We're looking at this area, 0, right? I want a 5% here, right? Right-hand side. So this number, right, will be T inverse, right? The right-hand side is 5%, left-hand side, 95.95, 15, right? This number, right? Now, if you're okay, let me show you the T table again. Make sure that you know what to do, okay? Because that is something important, okay? I think the set table, you have no problem, but the T table, I want to show it again, okay? Before I do that, let me wait for 10 minutes, sorry, for a second, because 10 seconds, sorry. Now if someone knows you're writing. Is that okay? Now, that's okay. Let me tell you how to figure out this number, which is 1.753, which is this number. You can find Excel. Okay. I show you how to do it in the T table, right? 15, 5%, okay? So that is a slightly difficult. Let me, is that okay? I clean up this one. So slightly little bit, have to be a little bit careful. The T table here, okay? I think I have 16, right? 16 is here, okay? And remember M-1, so it's 15, okay? The 15 table, okay? The 15 table. And remember one thing, okay? Remember one thing, what we're doing is we want the tail is 5%, right? So you have to be careful what table you're looking at. The table is two tail, right? You said two tail add together, right? I have one tail is 5, so I look at two tails 1%, right? Because this is two tail table, okay? So that's why I look at this number. Okay, of course, you can pick up whatever table you do, that's fine, but this is what the table I give, okay? Two tail, okay, the two tail one. Make sure that you pick up the right table, okay? You can pick up the table that you know how to work on, because you don't have to use my one, okay? Because you can create your own Excel, right? Create whatever you like, okay? So, some of you worry about the T table thing is, I would say, because we don't ask you to use Excel, right? So whenever I ask a question, it should be readable from directly table I put in the slide. So if you print this T table, then it should be enough for your purpose, okay? I will not ask more than this T table. So you don't need to worry about printing a more complicated T table, okay? This will be sufficient, okay? And in the worst case that you don't find your T table, you try to write the Excel function, we will give you partial credit for that. In case you really can't do it, we write the Excel function. If it's correct, then we would maybe deduct 1 mark from that at most. Okay? So your exact function is correct. Okay. So in the worst case, you don't know how to calculate, panic and forget, then write down the Excel function, we will give you partial credit for that. So don't worry about it. Of course, I expect you to find it, but if you really panic, okay, don't know what to do. Okay. Or you forget to print the T table, right? Otherwise. So now let me go to the other one. Okay. So this is T table, T again. Okay. So I have a N16, X bar 3, S is 2. Okay. So the same idea here goes on. X bar is here. Mu is actually 4. Okay. And as we know, okay, the data tell us it's 3 here. Okay. The question about is this 3 large enough from 4, right? Such that we would try to say X now no, X1 yes, right? If R is small enough, then you support X1 rather than X0, right? So that's the idea. Is that clear? And the question is, if we know the sigma square over n, then it's done, right? Because this is the shape we know very well, right? But the question we don't know. So what we're going to do is you convert this to t, okay, right? By the conversion is x bar minus mu, right, over s over root n, right? That's the formula, right? That's how you convert this guy. Every number here convert to here, right? 4 will be converted to 0, right? 4 minus 4, right, is 0, right? So every number can be converted. And phi is negative 2, right? If you can do that. So the question is this area, let me use the blue color again. This area, now convert to negative 2, is this area more than 5 or less than 5%, right? If more than 5, you don't. Less than 5, small enough, you reject, right? So remember this is T15 because n is 60, right? So how did that do that? It's very simple. That's T, this, right? Negative 2, which T table we're looking at? The 15 one, right? True, right? And compare to this, to your alpha. If you use 5% alpha, then you reject, right? 1% you don't, 10% you do, right? Is that clear? And the other way around, you use the critical value, which we know what to do already, right? We just do it, so I'm not going to repeat it, right? But the main idea is the answer is here, right? Negative 1.735, right? So your negative 2 is more extreme than the critical value, right? This number we call critical value, right? Because this is the number that is make or break, right? It's the point of no return, right? More than that, then done. Is that clear? So that's, as I said, it's where I'm repeating myself too much time, but I hope that will become more clear. Okay? So let me, is that okay? Is that done? Okay, I erase this and I do it again. I'll do a two tail. As you see, it's very, I would say, it's very boring for you and for me, but we'll do it, okay? Unfortunate fact, we'll do it for the two sides, okay? So we have two sides. You can see some people in the Zoom over the left because it's too boring. You're stuck here, I'm sorry, but. So we have same question, N16 x bar 3, S is 2, right? They got log equal to 4, log to 4, right? So the question again would be I have x bar, right? According to central limit theorem, right? Or by normality, right? This is 4 here, right? And the question is, now we have the data turn out 3 is here, okay? I want to ask this area, okay? And of course, also symmetrically, which is 5, right? The sum up of this area, is it more than alpha? Why 5? Because you don't know where, right? For you, it's 4. Before you do it, for you, 3 and 5 equally likely, right? Actually, when you come up with 3, then actually it's 5. Why you keep smiling? Is it very fun? I just wonder, is it something funny goes on in this question? But anyway, so let's see, right? The data we have is 3, right? So it's asking whether 3 is far away enough, right? Remember the area has to multiply by 2, right? Because you don't know which side you're doing actually, right? So you convert this to t, right? 16, so t15 here. So this is 4, convert to 0, and 3 convert to -2, as we have done, right? 5 is 2. Okay. So the question again is asking this area plus this area, is it more than 5%? If you 5%, right? If 10% more than 10%, so on and so forth, right? So how to find this small area here, right? That's very simple. The left-hand side would be just t, one area, right? This -2, the 15 one, true, right? And then multiply by 2. Why? Because left and right, right? And you can see, in this case, we can't reject, right? 6%, okay? So 10% we still reject. 5% no. 1% of course no, right? Because it's very clear. Is that clear? So this is the first time we fail to reject, right? For our example, right? Is that clear? Well, you should be able to tell from the question, but because if you don't say anything, it's always to tell. And usually, if I look at the past sample question or the sample question in the lecture notes, I will say, we want to test the hypothesis that whether the population mean is equal to 2, equal to 4 or not. So that is the anyway, right? We want to use a sample to test the hypothesis whether H1 is equal to 4 or not, right? Or the question will say, consider auditor want to make sure that it's actually 4, right? This will imply this is the case, right? So you really know the question, right? I cannot promise, I don't trick you, but I will try to make sure that it should be clear as possible, okay? Is that okay? So that's the part, okay? Is that okay? I'm sorry that we will be very boring again with some continue to be boring. Another boring thing. Is that okay? Yes. Yeah, actually, yes, because you don't know which side. Actually, if you don't multiply by 2 to compare alpha over 2. So the convention is you multiply the area and compare alpha directly, right? Because you imagine the reason is before you do it, you put alpha over 2 on both sides, right? You actually can compare this to alpha over 2. But the convention is, surprisingly, you multiply the area and compare to alpha. Does it make sense? Right? Because your question is very good, right? Because why I multiply these two, right? Why I just have this area and compare to alpha over 2, right? But there's a convention, p-value is just multiply. Because definition of p-value is the alpha area just to reject, right? The definition is smallest alpha such that you reject the HNL. Okay, so because you change the alpha, right, to both sides, that's definition. So not my invention, okay? So that's the way they do. Okay, is that okay? So very good question, but I do not invent that. I mean, which is not very natural, but I mean, of course, there's some reason why behind they define this way, but that's way beyond our class. I mean, unless you go to stat department, you never understand why they define that way. Okay, in B school, you never understand. Okay, how I understand? Yeah, because I go to stat department to learn statistics. So okay, so is that okay? Then we go to the other one again. I warn you, it's very boring. because what we do is do Z again, okay? Why we do the Z again? Because we do proportion, we don't have to worry about T, right? Because proportion, mean, if you know the mean, we know the variance, right? That's the main thing about, special thing about proportion. Mean and variance are closely related. So once we know the mean, we know the variance. We know variance, we can also say, right? So that's the idea, okay? So if we know the mean, the variance is well known. So always use that. So this is the formula, right? So let's go directly. Very boring, unfortunately. Let's do it, okay? I don't bother you with the one-sided test. I just do two-sided, but one-sided would be the same, okay? Because I already found very boring. So that's why I think I just keep this example only. It's very boring already. So suppose you have binary data, okay? And have sample size of 50 and sample proportion is 5%, right? So basically the question is, okay, I have no hypothesis, right? Say the percentage of male in CHK for undergrad is 40%, right? And I collect data, which turn out to be half of them are male, half of them female. So I want to see whether this is going to reject or not, right? And I want to see more than or less than because I don't really know, right? Which is whether 40% more, 40% less. I don't have anything to say, right? So the idea is the same because again, it's a bell curve. The P is a bell, right? P is X bar, right? Just remind yourself, right? In the proportion case, right? It's 0.4 here, okay? And do note that because I know this, I know the shape because by binary data, the shape, if I give the location, the shape is there, right? Because the variance is at 0.4, 1 minus 0.4 over n. Just to remind yourself, this is the case for binary data, right? When it's 0, 1, this is there, okay? Now we do that, it's very simple, right? Now we have, say, this is 0.5, okay? It's two-sided one, right? So we want to compare this to alpha over 2, right? If this is smaller than alpha over 2, then reject, right? Or 2 times this area, is it more than or less than alpha, right? More standard case, right? Either you compare this to alpha over 2, right? But or you multiply this area and compare to alpha, same thing, right? So that is simple. You convert it to this Z space, right? This becomes 0, right? And you convert this after very complicated operation. It's 1.44, okay? And the calculation is very simple, right? Just n is 50, right? Take a square root, put it there, denominator, nothing new, right? You can just remember the formula, right? Right? Just pi minus a, right? Over a times 1 minus a over n, right? A is this guy, right? I think you have that, right? And the question, again, you just try to check, right? If this guy is more than or less than half of alpha, right? Or you calculate double of this area, right? So this area is norm. By now you should know very well, right? As this, right? 1.44, true. Do remind yourself, should be 1 minus, right? But remember, multiply by 2. So that is very tricky, right? That's the p-value. So I may ask you to give me the formula for Excel. So be prepared for that, okay? Because I don't want to ask you exact calculation, right? Then I will ask the p-value, right? Because that would be more simple than in case you don't have the thing. But you should know, right? It's not something complicated. Is that okay? Done? Okay, very happy. Now, what's rest for this chapter? It's just like this. Give the formula, just apply. So very boring, as I said. I mean, Well, because, but as I said, it's very boring, but it's very important because that is the key thing you learn from this class. One thing is estimation, the other is hypothesis testing. Okay, the main two tools, right? Of course, you know ANOVA and regression, right? But there's the main two. So I would not try to draw you into more new formula, but we will do very quickly next class. But I will give you on Thursday. But I want to give you what we are going to do for the rest of the thing. But as you will see, it's very simple. I just plug in the formula all the time and show you why this is true and how to tell you. So we are not talking about 2 samples instead of 1. Okay. And why do 2 samples? It's very often we want to compare 2 groups. Okay. And that's usually what you do for your projects, right? Because suppose I want to say, is female consumer different from male consumer, say, or is the customer in the Hong Kong different from Shenzhen, right? Or is the hotel on weekend revenue different from weekday, right? We compare groups, and in 2 samples is comparing 2 groups, and we learn ANOVA, which we learn after this topic, comparing more than 1 group. Okay, suppose I want to see CHK have 8 colleges, right? Am I right? 8 colleges, 9? Okay, 9 colleges, right? We want to see, is there a difference between the colleges, the student body, right? Because when I was a student, only 4, right? But this is ANOVA, right? And if you want to compare t-test, we compare original 4 college is different from the new 5 college, right? And there's 2 groups, okay? And the way we do will be based on T. Actually, everything can be done in Z, okay? But we just don't want to make our life crazy, so we just do T, okay? And later you will see, depending on assumption, we will actually just, although I promise you not to go to the formula, but let's try to look at it, is you will do the same. This is another formula to plug in, okay? I mean, just basically you will learn new thing, plug in the new thing, the same formula. So same idea, whether this is too big or too small, okay? But I'm not going to get you crazy, okay? And again, you compare 2 proportion, right? The same idea. The idea will be saying, I want to see whether we have more female in accounting than the proportion in engineering, right? Something like that. Okay. And the last one will be something that we will discuss new. It's called F-test. Okay. F-test is comparing whether variance of one group is more than the others. Okay. Of course, we compare by sample variance. Okay. So because of only 4 minutes, I don't want to start new thing, and because I overrun last week by 4 minutes, so I should let you go. But I will stay here for 4 minutes or more to answer any question you might have. Okay, because I don't want to start new thing, because I think it's already very confusing if you don't follow. So I stop here. In case you have any question, just feel free to ask. Okay, because I steal some time from you often, so I let you go earlier today. Otherwise, you write bad evaluation for me, right? This guy always take away my time. So, but I will stay here, ask a question. So, any question, you can feel free to come in.